The first prediction that man would walk on the moon was made only 100 years after the death of Christ. The Syrian writer Lucian describes a Mediterranean ship lifted by a waterspout to a height 350 miles above the earth. When wind filled the sails, the ship was carried aloft for 7 days, after which it cast anchor on Earth's only satellite. That was the first science fiction book. It was not until the 1600s that men first tried to reach the moon. Galileo's telescope, by means of sunspot tracking, proved the sun itself rotates every 28 days. The features of the moon were now seen to be land masses, such as mountains and craters. For the first time, instead of a pale dot in the sky, Jupiter is shown to be another world with its own moons. At first, telescope tubes were made from lead pipe or hollowed-out wood. They soon became mass-produced, utilizing tubes of cardboard. Telescope mania was sweeping Europe. Men were speculating, if God made other worlds, surely he would have supplied them with life, similar to that of Earth. Were there people living there? Jupiterians? Saturnians? Venusians? They invented a name for moon men, Selenites, taken from the name of the Greek moon goddess, Selene. And while sitting at the eye of a telescope, they wondered if the Selenites were looking back at Earth. 17th century England was ruled by James I and later by James II, so this era is called Jacobean, because Jacob is the biblical version of the name James. The ancients were the supreme scientific authority, because the Romans and the Greeks lived so close to the time of creation, and they were less corrupted. The invention of scientific instruments like the telescope changed that attitude, for suddenly new discoveries were being made. Early scientist Dr. John Wilkins was the warden in charge of and responsible for the welfare of the student body of Wadham College. He was also a magnetic leader who gathered together leading geniuses of the age: Robert Boyle, Christopher Wren, Robert Hooke, and Christopher Brooks Mansell, among others, with the goal of attaining interplanetary spaceflight. Using trigonometry, they accurately calculated the distance to the moon as just under 1/4 miles, with an accuracy of 99.9%. In Wilkins' opinion, after receiving funding from 20 men, contributing $40 apiece, the space program would require only a set of good blueprints, a skilled blacksmith, and a handy mechanic. The power source would be large springs, whose strength would be increased by a system of gears after the springs had been compressed in the manner of pistons by the force of gunpowder. On New Year's Day in 1654, on the grounds of Wadham College. Aided by his team of early scientists, a test launch was conducted by John Wilkins on farmland owned by Oxford University of a missile fueled by gunpowder. The astronaut was renowned astrologist Nicholas Culpeper. Flight was achieved, and Culpeper rocketed skyward. But the vessel had not disappeared from sight before it pointed back, at a most fortuitous spot on Earth, to fall and plunge into a pond, which was covered at the time with a dual layer of snow and ice. Incredibly, the brave astronaut survived re-entry for 9 days before expiring from his injuries. The Jacobean space program came to an end, not from the sacrifices of its members, but when the experimental scientists of that era finally uncovered the problem of friction and its associated energy loss. The law of diminishing returns made it impossible to power spaceflight at man's current level of technology. But the most important advance had already been made, which was the break from complete dependence upon the knowledge of the ancients.
I've seen some of the experiments shown in this film actually carried out